Welcome. Welcome to today's video. And in this video, we're going to talk about trig ratios of angles of form pi over 2 minus theta, pi minus theta, 3 pi over 2 minus theta, 2 pi minus theta, pi over 2 plus theta, and you see pi plus theta, 3 pi over 2 plus theta, and lastly, 2 pi, okay, it's 2 pi, should be 2 pi plus theta. Alright? So we're going to talk about the trig ratios of these angles, and I'm going to teach you this thing using unit circles. Okay, unit circle. So let's first of all learn what's a unit circle. So a unit circle is just a circle with radius 1. So unit circle is a circle with radius 1, with radius 1. So we're going to teach you this concept using unit circle. So you have this, a unit circle if the radius is 1. Okay? And one more thing. On the unit circle, we have, okay, so let's say there is an angle theta here. Okay? Theta is the angle there. And if you project onto the x-axis a shadow onto the, if you have the projection on the x-axis, then this, the length of the projection here, this thing, is going to be cosine theta. And this, the horizontal distance, the vertical distance, the horizontal distance should be cosine theta, not the whole. Not this whole thing. The whole thing is 1. Does that make sense? The whole is 1, but I'm talking about this portion only. This portion is going to be cosine theta, and the vertical distance is going to be sine theta. Why is it so? Why is it going to be this? A simple fact, because the radius is 1. This is 1. So I'm going to prove you that this is going to be really this, what I've labeled here. It's going to be this because if you find sine theta on the unit circle, if we have the angle theta then if you find sine theta, then sine theta will be opposite of hypotenuse, so cut over. Okay? Sine theta is going to be opposite of hypotenuse. So it's going to be opposite divided by hypotenuse is 1. This is length 1. Which means sine theta is going to be opposite. So your opposite is sine theta. Similarly, cosine theta is going to be adjacent over hypotenuse is 1. So it's going to be just the adjacent. Does that make sense? So it's going to be just the adjacent. So the adjacent part, it means this is cosine theta. So this is the thing that you need to be familiar with in the unit circle to understand this concept. And also one thing, the coordinate of this point is going to be cosine theta, comma sine theta. If, let's say, it were another kind of circle, okay, not a unit circle, an ordinary circle, then there would have been an extra factor of r there. R, I call it the radius. There would have been r cosine theta times r sine theta. Does that make sense? It would be this. If this was an ordinary circle. But we know r is 1. So this will be disappeared, and we're going to have cosine. So r will disappear because r is 1. And it's going to be cosine theta, comma, sine theta. Pretty simple and a straightforward fact. Okay, one more thing, you can also see that one famous identity, one of the Pythagorean identity, is just visible here. That sine squared theta plus cos squared theta is equal to y. This is sine squared theta. If you square this, square the opposite, square the adjacent, is equal to square of the hypotenuse. And you can see that this is visible just right over here onto the triangle. Alright, so it was the preliminary thing, or the prerequisite that you need to know to understand this. And one more thing. If you have an angle theta, then sine and cosine are defined in this way. The vertical is going to be sine theta. The horizontal is going to be cosine theta. But what if you don't have an acute angle? The angle is obtuse or maybe other types of angle. Okay? Then in that scenario, if you have this angle, let's say, so this is no longer acute. Does that make sense? If you have, let's say, theta is there, then sine is going to be this here. This is defined that this will be this side is going to be sine. Okay? And this will be cosine. It is defined like that. So this is going to be cosine theta and this will be sine theta. In other words, the coordinate is the thing, the matters. The coordinate of this point is going to be cosine theta, comma sine theta, because the x part, again, the x coordinate is going to be cosine theta, and the y coordinate is going to be sine theta. Does it make sense? So if you have angles greater than 90 degrees, or no longer acute, then this is how it is defined on the unit circle. Sines and cosine are defined on the unit circle. This was the preliminary thing. Now we are ready to jump into the concept of this, the thing that we came here to study. All right. We want to know, first of all, we'll talk about pi over 2 minus theta. So we want to know what sine pi over 2 minus theta is, and what other ratios, the rest of the ratios are. But first off, let's talk about this. On the unit circle, okay, first of all, what does it mean? It means angles in the range 0, okay, 0 degree to pi over 2. It means this. Angle in this range. It means this. What the trig ratio is going to be our angle, and the form of trig ratio is going to be of angles in this range. That's what it means, because theta can be anything. If theta is 0, it's going to be pi over 2. If theta is pi over 2, then it's going to be 0. So in the range 0 to pi over 2. This is what this thing means here. Okay? So it means now, on the unit circle, if you draw the Cartesian plane, xy plane, then it means it is the first quadrant. This thing represents the first quadrant. 0 to pi over 2, 0 to pi over 2. This is 0, this is pi over 2. Okay, I'll label all of them. This is pi. This is 3 pi over 2. We're going back to 2 pi. So 2 pi and 0 are at the same position. Okay, they are different, but they are at the same position. We are in the first quadrant because it is this, and this tells us that we are in the first quadrant. If I know what sine is, okay, so from pi over 2 is this much. From pi over 2, we have to subtract theta. Let's say theta is this much. Theta is this much. So if we subtract theta from pi over 2, this thing left is going to be pi over 2 minus theta. Does that make sense? The thing remaining, the angle remaining, is going to be pi over 2 minus theta. And this is what we want to find out the trig ratio of. It means the sine will be this, cosine will be this. Sine will be this, and cosine will be this. What is our goal? What do you want to do? We want to write this in terms of theta. This is what we want to do. We want to write this in terms of theta. So highlight our goal. We want to write this in terms of theta. So it means we want to write this thing. Okay, so sine is AM. So this is pi over 2 minus theta. Which length is going to be sine for this angle? We already know this is going to be the hypotenuse. I'm sorry. The opposite is going to be sine here. Okay, highlighted many times. Okay, I'm going to mess there, but it still is clear. Okay, this is your sine. Why is sine there? You can use your trig ratio. I just define the unit circle right now. Tell you that the opposite is the sine, adjacent is the cosine. Okay, so the sine is this. For theta, what is sine here? We can see this is this angle, this much is theta, and for theta, this is sine. Why this sine? Because this and this, they are equal. Okay, if I label name there, if I label this is A, O, this is A, this is B, and this is C, then we know OC is equal to AB, and for theta, OC is adjacent. Does that make sense what I'm saying here? For theta, OC is adjacent. This is adjacent because it is lying on this Opposite means the side opposite to the angle. So if I make the theta, let's say smaller, then it's going to be less hard for you to visualize. Opposite is this side to theta, so that's why this is going to be the opposite. This will be the adjacent, and this is going to be the hypotenuse. So adjacent is this. So AB is equal to OC, and OC is adjacent for theta, which means AB will be adjacent for theta because they are of same length. Does that make sense? So the sine is adjacent for theta. So it means sine pi over 2 minus theta is adjacent for theta. And by the way, I want to write theta here. I want to make theta here. Why do I want to make theta here? Because theta is an acute angle and its position lies there. So I should remake theta on the horizontal or the starting line, which is the positive part of the x-axis. Does that make sense? This is the positive part of the x-axis. And I want to redraw theta there. The angle theta, I want to redraw theta. And this is going to be, sines and cosines for theta. And we know that this length is this here, this side over here. Okay, I will make clear that again because I know the figure looks not that great. So OC is this, OB, and OB is cosine, so it's going to be cosine theta. Again, we can make it clear once again if it's not clear. If it's not clear, let me make it clear once again in a good way because you need to understand this. This topic is kind of hard to understand, but you have to get your brain around it. Alright? Okay, let me do it bigger. Okay, it's fine. You'll understand in this kind of this size as well. What was I doing? I was talking about this. Pi over 2 minus theta. We're subtracting theta from this. And one more thing that I will do. I'll make so first of all, the remaining will be, this is going to be pi over 2 minus theta. The remaining will be pi over 2 minus theta. That's the first concept. That's the first thing that you need to understand. Next, I'm going to redraw theta here. Why am I doing so? Because if I find the trig ratio of theta, this will be same as finding trig ratio here. Because the trig ratio is defined, the starting point is the x-axis. The starting line. So the starting line is the positive part of the x-axis. Does that make sense? So that's why I need to redraw this. In other words, I need to rotate this by 90 degrees. Okay, I'm talking about this. And to rotate the base or the adjacent by 90 degrees. Or in other words, and to reflect this line about y is equal to x. About the line y is equal to x. Both are same thing. Whether I rotate this by 90 degrees, whether I rotate the adjacent by 90 degrees, whether I reflect this line, I will want to name it OA. Okay, so whether I reflect OA about the y is equal to x line, and then becomes here, let's say OB. I'm sorry, OB should be here. This is not OB. Okay, this is reflected about this line. They are same thing. Okay, and what do I want to know? I want to know this is we know here that this whole is pi over 2 minus theta, and we want to figure out what sine pi over 2 minus theta is. And we know that sine pi over 2 minus theta is this length. Our end goal is, what is this for theta? What this relation is for theta. And what this line, vertical line, is for theta. And for theta, we can see, first of all, we have to see here, for this theta. We can see that it is adjacent. It is adjacent, because it's not the opposite, it's the adjacent. Now, as this is the adjacent, it means this is this thing, for this theta, because theta is redrawn there, and for this, it is this, because it is just reflected about this line, but the line y is equal to x. Or, it is, the adjacent is rotated 90 degrees about the origin, okay? So it means this thing is adjacent. It means this thing is this. Does that make sense? And this is adjacent, and we can see that this length is sine. This length is sine, because this was sine, and this is same as this, and this is same as this. It means this is sine. Okay, so this thing was sine 4 pi over 2 minus theta, but for this, but for theta it is adjacent. It was cosine theta. So got this relation here. Okay, I hope you might have understood this. Okay, I hope this is clear. If it's not clear, watch it again. Then hopefully it will be clear for you. Okay, so this is the major thing we have got till now. Let's talk about now what cosine is. What cosine pi over 2 minus theta is. Okay, let's look. This is pi over 2 minus. Okay, let me redraw it again because I don't want to make it messy. I know when it becomes messy, it becomes very hard for students to visualize. That's why I keep redrawing the pictures as it gets more and more messy. This time I'll draw it big. This is theta. This is pi over 2 minus theta. I drew 2 lines then, curves then. This is, okay, I shouldn't draw the arrow because it makes it messy. This angle is pi here. This angle is pi over 2 minus theta. Alright? And I redrew theta. Theta gets redrawn there. Does that make sense? Or in other words, I distracted about the line. Why is it going to X? But I don't want to draw the line again. Okay? We're going to figure out what cosine is. Cosine pi over 2 minus theta is. For pi over 2 minus theta, cosine is this thing. Cosine is the base. Okay? Adjacent. Since the adjacent. Well, for theta, what is it? For theta, theta is there. So you have to see it here. For theta, what is it? For theta, you can see that this thing is equal to this thing. Okay? I'll label it again, leave names there. Okay? We want to know what OB is for theta. OB is equal to AC. Okay? OB is equal to AC. And AC is opposite. AC is opposite. Opposite for theta. AC is opposite for theta. So as this is opposite for theta, this is going to be sine for theta. Okay? This is opposite. This thing is opposite. Because this thing is this thing, and this thing is opposite for theta. Okay? It means this is this. For this, if you look at the theta here, theta is here. Okay? And for theta, this is opposite. So this is opposite. It means this is equal to this. This thing is equal to this. Opposite for theta. For theta. Okay? This is opposite for theta. It means this is sine theta. If this is opposite, it means for theta, and this is sine. Sine theta. Because opposite is sine. We called you. We told you that. Okay. Now let's learn the other ratios. Okay. Let's don't go in order because I want to leave other things on you. Let's talk about this. Okay, which one should I talk about? Okay, let's talk about this now. 2 pi minus theta. Will it be okay? Or should I talk about? Okay, let's talk about maybe this. Because theta one should be talked about more. Okay. Let's draw the circle. This is our unit circle. Okay. It's 3 pi over 2 is here. And it says 3 pi over 2 minus theta. So subtract some angle theta from this. Okay. And then redraw theta here back to its original position where it should be here, where it should be there. Okay. And the left, this is going to be the remaining angle because till here it was, from here to there it was 3 pi over 2, and the remaining will be 3 pi over 2 minus theta. Does that make sense? The remaining will be this. And we want to know what cosine 3 pi over 2 minus theta is. This is what we want to figure out. Okay? What cosine? And we know that cosine is going to be what? Which side is going to be cosine for this angle? So we ask for coordinate. The coordinate of this. We find the coordinate of this. Coordinate of this is going to be what? Cosine comma sine. Okay? The coordinate of this. So it means this is going to be cosine. Okay? And this is going to be sine. This is cosine, this is sine. We want to know cosine 3 pi over 2. It means this much length is cosine 3 pi over 2. Okay? And let's label names there. O, A, B. It means OA is what? Cosine 3 pi over 2 minus theta. Okay, OA is that. Does that make sense? OA is cosine 3 pi over 2 minus theta. And what is that for theta? This is what we want to know. So theta is here. So we need to find for this theta and translate it here. Translate this over there. Okay? So this length for theta is this. So let's name C. Let's name the C. If this OA is same as BC. Okay? OA is same as BC. But BC is what? BC is what for theta? It's opposite. It's opposite for theta. It's opposite for theta. BC is opposite for theta. And let's translate this back here. Opposite is this, so opposite is going to be this. It means this is same thing as this. And now here we're talking about it in absolute value term. In absolute value. The absolute value of this are equal to all of them. But we know and that this is negative. Let's talk about signs now here. This is negative. But this is positive. But this is positive. This is a negative. But this is positive. In between, this is negative. Opposite for theta. Okay? It is negative opposite for theta. Or if you don't want to put negative there, then you have to put, let's put negative there. Because it might seem that this is a theoretical thing, not a something mathematical there. It doesn't make sense? So I don't want to put minus sign there. But minus, and this is sine, because this is what? Opposite. This is sine theta. This is going to be minus sine theta. So you have to care about signs as well here. Sine is the thing that, so you don't talk about the things in absolute value, in terms of absolute value. You talk about in terms of what the real sign is going to be too. Don't talk about length only. We talk about in which is it the positive part of the x-axis or the negative part of the x-axis as well? Where is it? Okay? So it's going to be minus sine theta. Now let's do something interesting. Let's find out for tan. What is it for? What is tan? 3 pi over 2 minus theta. Okay, how do you figure this out? It's easy to figure this out. We just find sine 3 pi over 2 minus theta over cosine 3 pi over 2 minus theta. And I'll give you a hint. I just figured out this. You should figure out this as well and then divide both of them. So you're going to have the value ready for you. So I leave this on you to do. Okay? Let's talk about one more positive angle. Okay, one positive angle because we haven't talked about positive. Plus theta. Okay, let's talk about plus theta as well. We only talk about minus theta, don't we? And let's talk about plus theta as well. Okay, so let's talk about now this, pi plus theta. We want to figure out what sine, because if you know sines and cosines, you can find tangent there. And you can also find out cotangent. And there is reciprocal, like cosecant and secant as well. Does it make sense? Because it's just going to be, secant is just going to be 1 over cosine theta. And whatever cosine comes out to be, do the calculation. You're going to have the result come out. So you need to figure out what sine, okay, pi plus theta is. Let's draw the unit circle. This is pi plus theta. So pi is here, and now we add theta to it. So if you add this much theta, this would be this whole, this is theta here, and this whole is going to be, I added here, pi plus theta, pi plus theta. This whole is going to be pi plus theta. And what are sines and cosines here? For this, you know what the coordinate is. What the coordinate is. Look at here. This is the x coordinate, and this is the y coordinate. Okay? It means the x coordinate is going to be cosine. This is cosine, and this is sine. And don't want to write the angle. Angle, you know what the angle is. Since the angle is pi plus theta. Okay? This is your cosine. This is sine. You want to figure out what this is for theta. You want to figure out what this is for theta. For theta, you see the opposite. This is opposite. It means this thing is opposite for theta. This thing is opposite for theta. It's the opposite. Okay? And let's redraw theta here. Let's redraw theta here. Opposite means this. This is for theta. And this is positive sine theta. This is sine theta. This is sine theta. But we know we don't have to write sine theta because sine theta is positive. But this is negative. Because length is negative. You have to put the negative sign there. But this is how you do. This was the concept. I hope the concept is clear. But do you memorize like this? No. There is a way to memorize, and I'll tell you the way in the next video. Alright? And I hope this is clear. And I want you to complete for all of them. Okay? The two ratios. If you know sines and cosines, you can figure out the rest of the ratios as well. And this is how we do it. Okay? And the way to memorize it will be in the next video.